logarithms with different bases. We've talked about common logs. Now we're going to talk about natural logs that have a base of e. Now, because they're special calculus properties, logarithms with the natural base e are going to be used in many situations. Logarithms with base e are called natural logarithms. We often use a special abbreviation ln without a subscript to denote a natural log. Thus, the natural logarithm of function, log of x to the base e, is simply natural log of x. You guys need to pay attention to that. It is the inverse of the exponential function f of x equals e to the x. So this tells you then y equals ln of x if and only if e to the y is equal to x. Now we can rewrite this way. We can rewrite that way. ln of x is simply log of x to the base e. That's the only difference. It's just easier to write ln of x because we use it so much. Now, applying this relationship, we can obtain other fundamental relationship for logarithms of the natural base e. So just like we did with the previous logarithm charts, we're going to do the same thing with the natural logs here. So ln of 1 is 0 because e to the 0 power is 1. ln of e is 1 because e to the first is equal to e. ln of e to the y is equal to y because e to the y is equal to e to the y. E to the ln of x is equal to x because ln of x is equal to ln of x. All right? So what they're saying here is this. If this is ln of x, we flip it back here. ln of x is equal to ln of x. Now, using definition, or these basic properties. So we're going to flip back and forth. We're going to show one with properties. We're going to show one with using it equal to y. So I can rewrite this as ln of e to the 1/2 power, right? Yes? Which means then it's going to equal how much? Using the chart, we're looking at this here, it is equal to 1/2. Correct? Now, let's switch back and forth. So, we're given something in ln form, so we're going to use this. If y is equal to ln of x, then e to the y is equal to x. So what they're saying here is this. E to the y is equal to the square root of e. I can really rewrite this as e to the 1/2 power, which means y will equal 1/2. Same thing. Okay? A lot of times, though, the more you do this, the more comfortable you'll be. You won't really have to do that anymore. You just use the properties. You'll be able to see it right away. Now in B, what's our answer going to be? 5. Answer will be 5 using the properties. How about C? What about C? 4. Answer will be 4. Very good, Drew. All right. We're using the property here. E of ln of x is equal to x. This is the property we're using. Okay. In the bottom, in example C, we had e to the ln of 4 power. X is equal to 4. And that's where that comes from. Good? Any questions on example 6? All right. Now, if you really wanted to see it, e to the ln of 4, that's going to be equal to x. Switching this back, we'd have ln of x is equal to ln of 4. X and 4 in the same spot. That's why x does equal. Okay. This is kind of a more interesting property, a little more difficult to understand, but that's really what's happening. Okay. Looking at example 7. Natural logs can be evaluated by the ln key on a calculator, as illustrated in example 7. Now use a calculator to evaluate the logarithmic expression if it is defined, and check your result by evaluating the corresponding exponential expression. Okay? So again, ln of 23.5. So put that right in your calculator. We get this, 3.157. Now, if I wanted to check it, the inverse of ln to the x, or ln of x, is e to the x. So second ln, second negative, gives me the answer there. I do get 23.5. Okay? All right. ln of 0.48. I have here about negative 0.734. Second e of this, you get 0.48. Okay. What about the last one? This does not exist. Why doesn't this exist, Carl? The domain of ln of x therefore you cannot have a negative. Domain is 0 to infinity, you cannot have a negative. Are there any questions on example 7? Very well. Tomorrow we'll cover example 8, which is graphs of logarithmic functions. We're also going to measure sound using decimals, which is actually quite interesting.